Good evening, everyone. Can everyone hear okay? Welcome to the West Country Rivers Trust Science Evening. Thank you all very much for coming in such great numbers. My name's Dylan Bright. I know probably most of you reasonably well. I'm the director of the West Country Rivers Trust. The reason we're all here tonight is to talk about some of the work we've been doing recently, and it's our attempt to make science accessible. We've done it before. We call it a science soiree, if you like. There's just enough science to be tolerable, combined with some good company and some nice food. So we hope we've got the right mix. The talks you're going to hear tonight represent some of the cutting-edge work we've been doing recently. And to lead you into that, I'm just going to briefly tell you a bit about where we come from, because it's pertinent to that story. So, the Trust was initiated by a group of fishermen who were concerned at the decline in the quality of the salmon fishing. Anglers are very useful environmentalists. They keep very good records, they're very well organised into groups, and they barely ever exaggerate. As soon as we looked at this issue of declining stocks, however, we realised there were two main problems that we needed to surmount. First of all, fish depend on the functioning of the whole river from source to sea. And in that way, they depend on the land management of that whole catchment area. And every inch of land in England is in a catchment area. So initially our first challenge was that we had to deal with everyone, everywhere. And that's no small problem. But Nick and Lawrence are going to attempt to explain how we've gone about doing that. The second problem is that salmon go to sea and come back greatly reduced in numbers. So the second problem is we have to deal with everyone else, everywhere else. And Bruce and Andy are going to talk about how we've striven to do that. But the main message I think we want to convey from this evening is that a single plan for the environment should provide for all. Your starting point may be an interest in archaeology, food production, water security, salmon, sail bunting, golden eagles, dormice, dolphins. Your starting point may be any of those. But the plan you have should deliver your ambition alongside everyone else's, not at the expense of everyone else's. And I think what you'll hear from Nick and Lawrence tonight will explain why that's just, unfortunately, where we seem to have ended up. And the result is you end up with the tragedy of the commons, which I've put up here for us all to absorb. Basically, in economic terms, the tragedy of the commons is where a depletion of shared resource by individuals acting independently and rationally, according to their point of view, and despite their understanding that the depleting of the common resource is contrary to the group's long-term interest. And that's where we are, because at the moment, nearly everything is planned sectorally, delivered sectorally, and we're all tapping into a limited fund and competing with each other. So the first talk tonight is going to be about how we've tried to surmount that particular obstacle. I hope you enjoy it, and I'll hand you over to Nick.
So the responsibility for Lawrence and I is to start talking about the turf side of the surf and turf equation. And really, we're going to take you on a whistle-stop tour, half an hour or so, to introduce you to some of the work we've been doing in the planning and delivery of what we call catchment management. So we're going to couch this in terms of a story. We're going to take you through some of this work from the very start, right the way through to what we've done and where we're ending up in terms of delivering catchment management for real in various catchments across the southwest. So that's the what's called the Water Framework Directive Management Catchment for the wider Tamar. It's about 1,800 square kilometres of primarily rural countryside. The population is about 320,000 in total, but the vast majority of those reside in Plymouth and the surrounding area at the very bottom of the catchment. The Tamar is quite an interesting catchment in the sense that that's the way the population is skewed. The rest of the catchment largely rural, apart from a few towns. and primarily dominated by the agricultural industry, tourism, and other such interesting things. So, starting at first principles, we have this idea that a river catchment such as this landscape of the Tamar, provides us with a whole array of services that we get from the natural environment and on which we depend for our livelihoods, our health and our well-being. So this landscape provides people living in the catchment and elsewhere with food and raw materials, energy and fuel. And it provides them, if you live in Plymouth, with most of your drinking water. However, this catchment landscape also plays a key role in regulating the environment in which we live. It regulates climate gases and their impact on things like climate change and global warming. And it regulates the movement of water, both high flow, so it protects us from flooding when it's operating in a healthy and correct way, and it protects us from the harming effects of drought. As if that wasn't enough, the landscape is also required. We depend on it for spaces where we undertake cultural activities, we undertake our recreation and leisure, and it provides vital spaces and habitats for wildlife and indeed for ourselves to live in. So already we've captured this idea that this landscape is very important to us, and so from here we can then go on to start actually teasing some of this apart and trying to understand how these services are derived, where they come from. And that's where we're going with this catchment management story. So, all things being equal, we get those services from a catchment such as the Tamar, but actually there are a lot of pressures out there, a lot of things that get done, a lot of things that happen, which mean that the ability of the landscape to provide those services can come under pressure and can in fact be compromised. And there are a number of things that human beings do that can put pressure on the delivery of those services. And when the ecosystem comes under pressure, what happens is that its health can start to deteriorate, its condition, and its ability to deliver those services can then be compromised. And we see some of the environmental impacts, such as flooding and ecological degradation, deterioration of water quality, and on the bottom right there, the dredging of the estuary. So these are all signs that while we're beneficiaries of the ecosystem services that come from the catchment, we're also the ones who suffer when those services start to become degraded. So we can start again to think about, well, we're not getting all that. We know that those services come from the catchment, but how much of them are we getting? Where are we on this continuum? And these two illustrations show perhaps the balance of ecosystem service provision that you might get in two different catchments. One on the right, a natural, low-intensity exploitation system. It's in good condition. And the provisioning services, the environmental services, the ecosystem services that we get there, water regulation, pest control, wildlife, biodiversity, they're dominant in that system. As you move along the continuum and you move into a situation where a landscape is becoming more heavily exploited, so that balance of ecosystem service provision shifts. And suddenly things like food production, production of fibre and timber start to dominate at the expense of the other services. There's a balance here. It's give and take. There's always winners and losers. So what's being done? Well, this is always the first question. What's being done? We've got an idea of where we are and what we might be getting from the catchment, but who out there is looking at this? And so we went through and we tried to find out who was working in the Tamar and the environment, and we started finding that huge numbers of people, as Dylan mentioned, are working on different parts of the environment. And there are lots and lots and lots of publications, scientific studies, reports that have all been done to look at this, just the Tamar, to find out what might be done and what the problems are. And really this slide just illustrates this idea that there is a huge amount that's already being done. But somehow along the way, the total of this work doesn't seem to be delivering what we need in terms of a healthy catchment, delivering all those services. So we need to get into this. We need to go through all of this information and find out what the key common themes are so that we can start to find those key core principles that determine how this catchment works. And what we did was we were invited by DEFRA to host one of the catchment pilots. There were 25 in the country on the Tamar, and we took the approach that we would invite all local stakeholders and technical specialists and scientists from around the region and specifically in the catchment, and we would start investigating with them in conversation these different ecosystem services and try and come to a shared language, because all those reports use different languages, different terminology, and that's part of the problem. There's barriers there, so we needed to break all that down and try and take a group of informed people along to look at some of these questions. What ecosystem services do we get? Are we getting enough? And as soon as you start asking these questions, you're starting to look for data and evidence to back it up. Are there areas of the catchment which play a key role in the delivery of those services? Is there anything we can do to increase the services that we're getting? Where should we be working to get more? If we decide there's not enough ecosystem service of a particular type, what can we do to get more? Where should we be doing that to get the most for our money? Who's currently paying? What levels of success are we currently achieving? And if we're not achieving enough, where might we get the extra funding we need to go out and do more? So in one slide, I should say, the last time I gave this talk, it took an hour and 45 minutes. So hopefully it won't be that long today. But there's about 10 slides condensed into one there. But the key thing is that we created this catchment partnership, and we worked over with about 100 plus local people to try and develop this shared vision, this shared language. So we took them right back to the first principles. We need to understand how this. The first example I'm going to give, that I'm going to explore in any detail, is the ecosystem service of water quality, and the way that a catchment provides us with fresh, clean water that we and the environment need to sustain itself. So the water cycle. Water falling on the earth is, to all intents and purposes, clean. And as it runs and collects across a watershed, so it makes its way to a watercourse, and from there, the environment benefits. We benefit because we abstract that water to drink, to treat and drink. And as this process occurs, if it happens in a healthy landscape, then things like flooding don't occur to too great an extent, and it protects us from drought. So it's one of the fundamental principles that sustains life on Earth, let alone in the Tamar. And this process is dependent on three key things. It's dependent on what happens to the water, which way it moves when it arrives on the surface of the land. Does it flow across the surface? Does it flow downwards into the soil? And the rate at which it does that, the rate at which it runs off, how long it's held in the landscape before it's released, these are key factors which determine whether or not this service is actually achieved in a proper way. And then, as that water moves through the landscape, does it come into contact during that passage with contaminants, things that it encounters along the way, whether it's sediment or whether it's pesticides or whether it's nutrients? As that water is moving, it can mobilise those pollutants, and it can take them across the landscape and into the watercourse, and then it becomes a problem. Then your ecosystem service is being degraded. So when it's working, we get ecologically healthy rivers, we get good treatable drinking water, and we're protected from high and low flow situations such as flooding and drought. And the key thing for us in this, working with our stakeholders, there are some bits of this landscape which play a greater role, a disproportionately larger role in the regulation of this process, because of their character, because of the way they are, and also because of their condition, the way that they're treated, the health of the landscape, the health of the soil. So fundamentally, we want to understand, why is water quality coming out of a catchment such as this one? Why is it good? Why is it bad? What locations are having a bigger impact? And this key principle that we use is this idea of source pathway receptor. As water moves through the landscape, if it encounters a contaminant, a pollutant, and it mobilises, it picks it up, that becomes a pollution source. As the water then continues to move, it can carry that pollutant with it along a pathway, ultimately arriving at the receptor, which is the river. And so we have to understand what the potential sources are, what the potential pathways are, and how those interact with the receptor. And we have this matrix that we came up with on the train, which is where all our best ideas happen, trying to tease out this idea that certain bits of the landscape, because of their character, are inherently risky to water quality. And then superimposed on that, on the vertical axis, we have what we do to the land. Practice, things that people do, whether it's farming or other practices, development, whatever it might be, flood risk management. What we do on a piece of land can also have an impact on water quality, and it's the interaction of the riskiness of the ground and what we do on it that creates our threat to water quality. So the matrix is useful because it shows us that what we know, which is that if you do very, very damaging things on low-risk areas, the impact may still be quite low. And if you do, you can do quite undamaging things, follow good practice on high-risk areas, and you can still create a pollution. But this top right-hand corner, this 9 up in the corner, this is where we're really interested in. This is where we need to deliver what we do, our catchment management, to improve this ecosystem service. Risky practice on risky land, that's where the opportunity is to go out and do something and achieve. That's where the headroom is to achieve a real enhancement of ecosystem service provision, in this case, water quality. So again, very quickly, I'm just going to take you through some of the data, the information that we use to try and characterise riskiness, innate riskiness, and where the greatest risk of water quality degradation occurs. So soil, we always start with soil. The type of soil, the innate character of the soil is really important because that's the first thing that the water interacts with, apart from vegetation, obviously, on the surface. So a wet clay peat-based soil with impeded drainage is far more likely to generate runoff. And if water is running off across land, it's more likely to mobilise pollutants that are present on the surface. A sandy soil through which the water infiltrates very quickly vertically downwards is also a risk because pesticides or other pollutants in the soil can be mobilised downwards and move through the soil into the watercourse. So understanding that there are high, medium and low risk soils is important, but also bearing in mind our matrix, which is that yes, some soils are risky and others are less risky, but also what we do to our soil, the condition of the soil, is also vitally important. So you can take a low-risk soil and do really damaging things to it, and it can generate pollution. But then we moved on, and we thought about, well, what about land use? What about the way that the land is used and the intensity of that use? So we can look at the data, and there's a myriad of different ways of assessing the way that land is used. In simple terms, we divide it up into land that's cultivated. Land that's cultivated, in basic terms, is probably more risky for water quality than a permanent pasture, uncultivated land, agricultural land, and that's probably a little bit more risky than a natural habitat. But having said that, we must remember our matrix, which is that if you can still do things, you can increase the intensity with which you use these different land uses and generate pollution. But high-risky practice on high-risky land use is where, up in the right-hand corner there, which is where the greatest potential threat is. And finally, the shape of the land, the shape of the landscape. As you saw in the very first slot of these slides, which is that the water arrives on the land and it flows and runs. That's what a catchment is. That's why we have rivers and catchments. So we worked out with the stakeholders that fields next to rivers were much more risky than fields not next to rivers because there's no pathway. When a pollutant is mobilised on a field immediately adjacent to a river, there's no pathway there. It's just a direct connection to the river. That means that if you do something damaging and a pollutant is mobilised, you've got much less chance to stop it. A field that's further away from the river, there's a number of areas where you might disconnect the pathway. Steeply sloping ground generates runoff more readily than flat ground. And we can actually create a hydrological model to look at subtle undulations in the ground to try and predict where water might run, particularly in high rainfall situations. Where does water run and collect across the surface? Where is the greatest risk that pollutants, if available on the surface, will be mobilised? So that summarises what we did with the Working Group for Water Quality. We identified that soil hydrology and condition was important because it can create runoff risk and leaching risk. The slope of the ground is important because that can generate water, can make water run off too quickly. Hydrological connectivity, if land is close to the watercourse, it can be a greater risk. The floodplain is important. Surface and subsurface flow of water is potentially, if it happens too fast, in the wrong places, can mobilise pollutants. And land cover. The harder you farm, or the greater intensity with which you do something on a piece of land, the more likelihood you are to damage it and therefore generate problems for yourself in terms of water quality. So that's the water quality in a nutshell. But we also went on with other working groups and we looked at flood risk. We tried using the same principles to identify key bits of land which were inherently risky for each, or important for each of these particular ecosystem services, and where practice might be changed in order to get benefit. Carbon sequestration, spaces, habitats for wildlife, ecological networks. Where is the greatest opportunity to create habitats? Where, if you create a habitat in the landscape, will you get the most environmental benefit, the most biodiversity for the minimum amount of resource? We also looked at recreation. We cast our net wide in terms of looking for the way that people benefit. If you can identify beneficiaries from a landscape, then you can identify where they derive that benefit, which bits of land are important. And we looked at land value as well, to identify where is the most productive ground, because that's important too, because this is about balance, this is about rebalancing those ecosystem services so that we still get the food that we need from our landscape, but we also start to get more of these other ecosystem services. And bringing all of those layers together, we then produced a final output, which is this map of the Tamar catchment. And simply put, this map just shows areas of the darker blue it is, the more of the ecosystem services coincide. So those dark blue areas, no surprise, on the slopes of Dartmoor and Bodmin Moor in the east and west respectively, those are key sections of the landscape. Dartmoor provides recreational resource for people. It plays a key role in regulating high and low flows of water. The peat bogs purify water, and it's vital for biodiversity and wildlife as well. So those are multifunctional areas. If you deliver something into one of those multifunctional areas, your hope is that for whatever reason you did it, you may actually get benefits in multiple ecosystem services. So you do one thing for one reason, and you actually get multiple benefits because you're doing it in one of those multifunctional areas. So in terms of strategy, we can't do everything, we can't go everywhere, we can't assess every farm, we can't look at every field. But where should we go first? Where should we go to go and investigate that matrix of risky ground and then try and find where people are doing damaging things? Because that's the opportunity to really get a big bang for your catchment restoration buck. So, that's it for me.
Save your rapturous applause for later. Nick's kindly left me with about 10 minutes to finish off a half-hour presentation, but ultimately, sort of Nick's picked out sort of the technical side to that mapping exercise, and trying to effectively speak the same language from all these disparate groups, which is no small task. What I'd like to pick up is actually how you start using that, what that looks like when you start working on the ground. And really, there are three types of tools you can use for working on the ground. There's the regulation, the polluter pays. This is where if someone's doing the wrong thing and it's illegal, they should be stopped. That's nice and simple. That system's in place, so the Environment Agency can go out and perform that role. We haven't got that power. I don't have the power to enforce law, but what I can do is talk to a farmer, talk to a landowner, talk to someone who's providing those services, those benefits, about win-wins, things that they can do to save money. If you make better use of nutrients, you're saving money, but also saving the water course. So we can start doing that. For the last 20-odd years we've been doing that, almost 20 years we've been doing that, to quite considerable effect. But there comes a time when a farmer can't do that because it may cost too much to put that intervention in place, or it might not benefit them that much to do that. And that's where we start looking at incentives, where we'd say the provider is paid to do that. Now there is one fourth one, which I don't tend to talk about that, and you can kind of sum it up by, put your hand up if you recycle at home. Yeah? Okay, put it down. Now, put your hand up if you're either paid to recycle, forced to recycle, or save money by recycling. No one. Yet we still do it, and it's because of the fact that we think it's the right thing to do. Yeah, but if I said to you, you had to travel 50 miles to do your recycling, suddenly there would probably be less people doing it. And that's why, yes, if we can get people doing the right thing, it's brilliant, but it's usually the first thing to go when the times are difficult. So anyway, we've got those things in place now. What I'd like to talk about is the incentivisation. Is that giving a bit of finance, giving a bit of a shove to do that. And What in the modern parlance that's been coming up in the last sort of 7-8 years is the term paid ecosystem services, or payments for ecosystem services, where effectively you've got a situation on the left where the farmer's managing their land for private profits. You look at it and think, rather than intensify that land and keep it as it is, we'd like to extensify it. You'll have some profits still on there, but what we've realised is by doing that we'll have an improvement in other ecosystem services. Now the trick is, to try and evaluate that and work out what that might be, which is one very difficult thing with a lot of controversy behind it. But the other one is actually to get someone to pay. I've seen studies that say the general public will pay £20 for an otter. Does that mean I can go to the pub and have one with chips? Probably not. But what it does mean is that they are of value, but trying to get someone to pay for that is very difficult. But effectively, in theory, the idea is that you can pay the farmer for either their profit foregone that gets them over to that threshold here, or if there was an actual genuine market for biodiversity, which lots of people are looking into, and we've already got one which I'll talk about at the moment for water quality, and we've got one for flood risk, an sort of entrepreneurial farmer could possibly exploit all of those to deliver them. But at the moment they're not really markets in the same way as the provision of an apple or the provision of a ton of wheat. So, in theory, what do? You have a buyer, you have someone who wants to buy that ecosystem service. They know they want it, but they don't really have a relationship with the farmer. You have a seller who wants to sell those services. Not all farmers we work with have dungarees and pitchforks, just as a side. There's a seller. He knows he can sell that ecosystem service or provide it, but he tends not to know the buyers. That's why those systems haven't set up yet. And then you can have intermediaries, and they know both the seller and the buyer, and they know about the regulatory framework to start thinking about, can this be delivered? Can you actually provide a service? So in practice, how has that developed for us? Well, at the moment, we're running Upstream Thinking, which is a South West Water funded project. They looked into what the costs were of having increased treatment costs, and then looked at what catchment management might be able to do, and basically decided that they'd like to give catchment management a go and see whether that was more cost effective than just carrying on with degraded water and having to treat degraded water. So anyone who's in the South West Water bill paying area will have had effectively over the 5-year period for the periodic review will have had effectively 65p taken from them. That generates £9 million, which they can spend on catchment management. Now, they don't have a relationship with the farmers in the West Country. They're out there. They can instigate works. They can change their practices, but they don't know of South West Water as in this capacity. But we do. And what we can do is we can ensure that the things we're trying to implement don't degrade other services and start delivering some of the things they want, but also try and minimise the administration costs and monitor that concept. Because ultimately, South West Water do want to get water quality out of it. That's why they're doing it. They're not doing it necessarily out of the goodness of their heart. They're a business. This is a business decision. The nice thing is hopefully it will benefit far more people than just South West Water. So, what does that mean in practice? Well, that £9 million has been distributed across all those blobs. And for the last 3 years, we've been going out ourselves, Cornwall Wildlife Trust, Devon Wildlife Trust, FWAG, and they went to administration, but we're managing some of that work on the Otter. Dartmoor National Park and Exmoor Mires is being managed by South West Water themselves. So, what does that mean? Well, Nick's map showed us some blue areas. And the blue areas are areas where we know there's potentially high risk, there's connectivity. But we also know that actually there's a lot of issues with infrastructure in that land. So what we've been able to do is look at the infrastructure. And this left-hand side of the picture is all the things that we find out on the landscape. If you go out to any farm, often you'll find some of these things. Not necessarily because of the fact that the farmer's hell-bent for causing this, but mainly because of the fact that the last 30 years, There hasn't been the investment, so we're seeing a lot of facilities that haven't been invested since the 70s or the 80s that are coping. They're legally compliant in a lot of places, but we have slurry pits go every couple of months or so. That we'll see a slurry pit go 300 tonnes of slurry into the river. They get a £20,000 fine. They then have to sort their slurry facility out. It doesn't suit anyone. We don't want to wait for that risk to happen, but it is legal at that time when you go out and look at it and it hasn't failed. So we can go out there, we can do these solutions. So one example, you go out there, the farmer wanted to fence the cattle out of its field. He benefits, we benefit. He got 3 quotes. We offered him a fixed percentage. We offered him 50% because he benefits from it. He signed a 10-year contract to say he'd maintain that. And we went to fence the river. We've got more glamorous pictures of fencing, but that's the nuts and bolts of it. In a year's time, that looks like all greened over. The actual channel inside is has got more vegetation growing in it. It's a nicer place for actually anything living in it compared to the cow defecating straight into the river. Not really surprising. Another example, someone with a yard system, that the water that falls onto this yard falls directly onto the yard. Any nutrients or any slurry that's on the yard, it flows into his slurry pit. It it can overwhelm the slurry pit, but most of all, it just fills the slurry pit up faster. He has to go and spread it more regularly. If he's spreading it at the wrong time, we know where it ends up. We always say the difference between a good farmer and a bad farmer is about a week. And it's that ability to be timely with your operations. So what we can do is we can look at how we can improve that. We can put a facility, cover that yard. Again, looking at a fixed percentage, again 50% in this case. Signed a 25-year grant. That one's because of the fact that it's a long-term project. And he signed a covenant that ties that contract into his land, into his deed. So in case he was sell, that still maintains. They still have to maintain that facility for that function. If needs be and there's something that does change, they can come to us and talk about what that is. But it gives us the security that we've not only got that for now, but also for the lifespan of that facility. And we can go on and make these things happen. So what does that mean for upstream thinking, at least? To the March this year, we've done 862 farm visits to 267 farms, so quite a lot of repeat visits for a lot of the work we do. 197 farm management plans. This is not the trust as a whole, this is just one project. 91 farm projects, totalling 1.6 million. I won't go through all the figures, but effectively 91 of these 91 projects, 66 are complete, and what we've found is the average grant out there is 48%. So a lot of value coming from the farmers themselves. And of these, quite a large percentage have that 25-year covenant, so quite a long time frame we're looking at. Now, obviously, South West Water aren't just buying the interventions, the bits, they're also buying what the outcomes are. And we can model those outcomes. We can look at how much phosphate might be being stripped out of the river. So if we go from this left-hand picture to the right-hand picture, we can see what will happen to the phosphate, and so we can model, even though it's uncertain, there's a lot of variables in there, we can start talking about how it might vary. The upper sections are actually, it contrasts against Water Framework Directive levels. So we can see not only do the water company benefit, but also the Environment Agency and DEFRA, when they're trying to get us to meet Water Framework Directive benefits from these sorts of approaches. And that information of how many tonnes of phosphate and nitrate we might be stripping out can then be used by South West Water at their treatment plants to sit there and say, OK, how much does that have an effect? Have we got our sums right on that cost-benefit analysis? Even though that's just one part of the benefits they derive. So we know we've got our delivery framework, the win-wins, the regulation, the incentives. We've got our toolbox. We can do the farm infrastructure, the farming best practice, the fencing off elements. We don't do as much habitat creation as maybe other groups, but there's all of these interventions that we can use in our toolbox for getting that land management change, getting that those improvements. And we also know where we can do it. We've got that blue sort of map of some of the areas we might want to start investigating and working with. And importantly, that blue map also shows where everyone else stands to benefit and why other people might want to come in. So what that looks like, and this is something we were playing around with for the Tamar pilot itself, is it starts to look like a map of what you might want from the future. What are some of the things we might want? And it allows us within the Tamar pilot to get to a better understanding with the stakeholders of what we get from that catchment, who stands to benefit from changing it, and importantly, who might fund that. Because if we want to shift from this more intensively managed system in places to perhaps a more balanced system, we need to have that idea of what we're getting, where we're getting, and who benefits. So ultimately, if we were to put this in our ecosystem sustainability meter and we had that intensive use and perhaps an unbalanced use, we might be able to shift to a system where we're getting a more balanced use of the environment. Now that's been 35 minutes. I never get more than 15 minutes at a conference these days, which is unfortunate. So one of the things we've been doing, thanks to the Collaborate project, is actually trying to put that into a condensed 2.5-minute form. Now I'm going to show you something which you're the first ones to see this. So we've tried to condense all of what we've just said into 2.5 minutes. So enjoy.
We live in a world where there are more and more people all living in a limited amount of space. The challenge we face is that all these people need a lot of things from the planet, but what the land can provide is limited. So how do we know if we're getting all the things we need? It helps if we look at the benefits the land provides as services, such as food, energy, drinking water, flood protection, or just a place to play. How do we balance these services wisely to meet society's demands? With the right information, we can make the right decision for any area of land. Such as, is it suitable for food or energy? Does it conflict with other services? Or do we get several services from the same area? But how do we find out what the land is capable of providing? First, we need information about the different services we get from the land. However, some of this information may not be available or may be incomplete. Some might be out of date or have the wrong resolution, or represent subjective views which are hard to evaluate. To overcome this, we need to review the information and what it means to our society. We must divide the land up into manageable areas, such as river catchments. Rivers drain the land and are good indicators of how well we're managing these services. If we get the right balance, we can maximise the amount we get from the land and still end up with a healthy river. Thanks to the help of the landowners and communities who live and work in our river catchments, the process of collecting information has already begun. By mapping these services, we can show what the land is suitable for, where land can provide multiple benefits, and where there may be conflicting demands. We can use this information to make better decisions about funding and managing our shared resources sustainably. When we do this, the environment, society, and the economy will all benefit.
Hopefully that's been a sort of far longer time than I usually get, and I hope you've enjoyed finding out what the catchment management side of the trust does, and thank you very much.